day is the 19th.
So I got two.
Right. Perfect.
Figure out what first one.
So it says, yeah. No, I just don't need glasses to read the close. Okay, so 4 over x plus 1 minus 1 over x minus 1. So 4 over x plus 1 minus 1 over x minus 1. Is it 4 over x squared minus 1? Just double check.
Yeah.
Make sure yes, everything correct? Good. So I'm given an equation to solve. Obviously, it's an equation because it has the left-hand side equal symbol and the right-hand side. So this is an equation. How do I start? What is going through my mind?
What section is this for?
Say it again. Exactly. Awesome. Awesome. So what type is it? Rational. Very good, because it has a ratio and it has x in the denominator. So this is indeed a rational equation.
What section?
1.6. Okay.
This section is one. Just tripping me out.
1, 2. Sorry. Other types is, yeah. Okay, good. So what do we do with the rational equation? Yes, we have to solve it, but what is the first step? That's true.
Move 4 over x squared.
Yes. And I have then 4 over x plus 1 minus 1 over x minus 1 minus 4 over, what is left here?
0.
Absolutely. And what do I do with this?
Break it into
Yes?
x plus 1 parentheses x minus 1.
Awesome. It's a difference of squares, which is x plus 1 times x minus 1. Good. I need these numbers.
1 and negative.
Very good. Indeed, two restrictions, 1 and negative 1. And now I would like to find the least common denominator, which is, yes? Yes? Awesome. Very good. So now we know that we cannot simply copy 4 minus 1 minus 4. That would be incorrect. We have to find the adjustments. Awesome. Awesome. Right. Or just forget it. You don't have to write 1. I just want to put it in. Okay. So now carefully, let's write the numerator. Very good. Awesome. Awesome. I didn't hear. I'm sorry.
Minus 1.
Good. Yes, perfect. Do we all agree with all steps? What do we do next? Good. So let's combine.
3x.
Perfect.
Negative 1. Minus 1.
Okay. 1,
Oh,
2,
shoot.
3.
No, minus 5.
Good. Over x plus 1, x minus 1 equals? Yes, just to remind me that now I can, only now I can. Very good, awesome. So let's do that. Equals? Perfect. This times this is on the left-hand side equals this times this, which happens to be 0. Perfect. So then this is what type of equation now? Awesome. I move 9, divide by 3. What is my first thought, my first concern, my first? Yes. Is it among those? No. So I can still go back and check, but I'm pretty confident that this is okay. Any questions? Any questions? Is this okay?
I think that's exactly what I put. And instead of
They make mistakes too. If you by mistake you put a dot,
oh, no, I put negative.
that's okay, no problem.
Then the second one.
Yes. Yes, ready? Any questions on this problem? Anyone? Any questions? Okay.
So it's p equals 0.8x minus 0.1 over 0.8x plus 0.2. It's a word problem.
That's fine. Yeah.
Okay, so the model P, well, the model up there is a learning.
So is it P or P of X?
It's just P.
Okay. It's still a function of X, so
Yeah.
that's
so
fine.
Where P is the proportion of correct responses after X trials. If P equals 0.
Hold on 1 second. We have to take notes. Trials. Number of trials. Very good. P is in percent, and X is the number of trials. Good.
If P equals 0, there are no correct responses.
Okay.
If P equals 1, all responses are correct.
So this is 0% and this is 100%.
So how many learning trials are necessary for 0.94 of the responses to be correct?
0.94 of the responses. So in other words, P equals 0.94. And we want to find X. Very good problem. Very good problem. So one more time, let's discuss this before we analyze and we decide what to do.
What number of pages is this?
This was one of the homework problems. It says it's on it's section 1.2, question 103.
Okay. 1.2, section 1.2, problem 103. Very good. Awesome. Okay. So we are given an expression. We are told here this. What type of expression is that? Exactly, because it has a ratio and it has X in the denominator. Awesome. So we're given a rational expression and we are told this rational expression represents percent of success. Doesn't matter. Anywhere between 0 and 1, right? 0% to 100%. Then we are told X is the number of trials we repeat the experiment. We can repeat the experiment, whatever number, 100,000 if you want, or 50. But we really want to determine that number such that the percent of success is guaranteed to be 0.94. How do we start? What do we do? Exactly. Exactly. So 0.94 equals
0.8x minus 0.1
divided by.
0.8x plus 0.
Did I copy this correctly? Is everything correct? Good. Now I'm going to ask myself what? Exactly what we just did a few minutes ago.
Can you cross multiply?
What is the first question? Awesome. But what is the first question? What is it? Right? Because it can be linear and I have a certain recipe. It can be quadratic and I have a different recipe. But you already are ahead of me, which is fine. So it is what? What type of equation? Rational. Awesome. Very good. So we are ready to indeed cross multiply because this is already a proportion. Very good. So I should write that 0.8x plus 0.2 can never be right. But in this particular case, it's not going to be 0 because look what happens. 0.8x equals not equal negative 0.2, and x cannot be a negative number. X is a number of trials. So the denominator will never be easy. Will never be 0, right? So whatever x I have, number of trials times 0.8 plus 0.2, this will never be 0. So this is already fulfilled. I don't have to state restrictions. So then I will write 0.94 quantity 0.8x plus 0.2 must equal
0.8x minus 0.1.
very good. Perfect. What now?
Should simplify.
I can't just yet.
You have
Of
to
course.
distribute.
Of course, perfect. I have to distribute. So let's multiply 0.94 by 0.8 and see what we get. As you see, I'm
0.752.
0.752. Very good. X plus 0.92, 0.94 times 0.2.
188.188.
0.188 equals, thank you, point X minus 0.1. So next, now I'm ready to move terms around. So what do I move and where?
Move the 0.75.
I want to keep the variable on the left hand side. It doesn't matter. Don't erase anything. Keep the right on the variable on the right if that's what you want. So 0.8x minus 0.752 is negative 0.048. Am I correct?
What are you moving where? Okay.
So then I move 0.188 to the other side, and I get negative 0.288. Final step. By this. Very good. So both are negative, so the answer will be positive 0.288 divided by 0.048. So X is the number of trials. To guarantee if the model still holds, I don't know, right? Assuming that the model still holds, then we need, what is the number of trials? So 0.288, or I should say 288 divided by 48. So I got 6. So 6 trials, assuming the model is still correct. Very good, perfect question. Anything else? Do we have anything else?
This
Say it
question
again?
was different in my book.
There's another one question.
Of course, they're all different.
There's another one.
They're all different. No two students will have the exact same question.
Really?
Yes. 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 They generate automatically different questions. Yes. But it's the same thing. You
Yeah,
just
yeah,
don't
yeah.
have the same idea. It's just that you don't have the same P of X. Yes. Very good. Any questions for me? Anything else? I would like to go back if you don't have other questions. I'd like to go back to finish up the problem that we could not finish last time on Monday. Yes? Very good. So let's start from scratch. Let's see if we haven't done anything. So we have f of x, negative 3x squared minus 4x and plus 2. And we are asked to determine and simplify the difference quotient. Okay? In this class, you do not have to memorize the difference quotient. All my other students in pre-calculus and calculus, they do. They have to memorize the difference quotient. In this class, it will be given to you. So we're asked to find the difference quotient, dq, which is f of x plus h minus f of x divided by h. Now, I see 3 pieces here. I see this piece, I see this piece, and I see this piece. Which of these 3 pieces we have, and which one we don't? Let me ask you this. Do we have f of x? It's very clear. It's right here in front of us. Good. So that's done. Do we have h? Or can we do anything to it? No. It's just a letter. We can't do anything to it. So which of these 3 pieces we have to calculate then? Indeed. This is the piece we do not have. And this is the piece we have to determine. We know how to read this function. Can anyone read this function for us? F of blah equals
Negative 3x squared.
blah squared minus 4 times whatever plus 2. So then when I try to determine f of x plus h, what will you tell me to write?
Negative 3
Awesome.
times x plus h.
In parentheses, very good. Minus,
4.
very good.
And in parentheses, x plus h.
Yes,
Close parentheses plus 2.
perfect. This is good, but it's not good enough. I'm not going to put it in this form in here. I have to continue.
So question.
Yes.
If when the problem started it said f of x plus h equals blah 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 blah, then we would try to find f of x.
F of x is given to us.
No. Right. But if instead it started f of x plus h, then we
It cannot be given like that.
Okay.
Very good question. Very good question. It cannot be given as f of x plus h. We are given the function, and we are asked to find the corresponding difference quotient for the given function. So f of x plus h will not be given to us. We have to find it.
So almost always we'll be doing
F of x. Yes. We are
Right.
given f of x, and we're asked to find the difference quotient for f of x, and we will have to calculate f of x plus h.
Right.
Good. So let's continue. How do I simplify this? I cannot distribute because I have a power that is more powerful than
Of the
multiplication.
FOIL.
And we don't FOIL anymore from the first day of classes. The first document we filled out, I said, please stop foiling so we can move on. Please. Yes, go ahead. Yes, indeed, but I have to copy -3 first. Yes, perfect, awesome. Very good, awesome. Awesome. Very good, thank you very much. First day of classes. First document we filled out. Our first agreement in this class. And I said, please don't slow us down. Please do this now, forever. You see, it pops up every class. That's why I wanted to get it out of the way from day one. So this is -3x squared minus 6xh minus 3h squared minus 4x minus 4h plus 2. If you still have difficulties with that, please see me anytime so I can help you with that. Yes?
But if you fuel it, will you say I'm the same?
It will take you 5 minutes instead of 2.
Okay. But
And you will have difficulties factoring. That's why I want to leave that behind. This is O11. This is beginning algebra, foiling. Please leave it behind. Please, I'm begging you, leave it behind. So then, now we're ready. So let's continue. After we put it in, yes?
Oh no.
After we put it in, I will remind you, or I will tell you, because I didn't get the chance to tell you last time, what has to happen. There are 2 things that have to happen with a difference quotient for every function. Every function. 2 things have to happen. Good. So please dictate. I have to replace this by what? Exactly. Expression. -3x squared minus 6xh minus 3h squared minus 4x minus 4h plus 2. And now I reach this stage. This is where I'm at right now. Can anyone dictate the rest? Yes? Very, minus this.
Oh, yeah, nice.
Minus this.
Yeah.
So
Minus fx.
I don't want to write parentheses. I like to, yes, plus.
3x squared.
Perfect.
Plus
Awesome.
4 minus 2.
Excellent. And the denominator is h. Let's stop for a moment. All we did was we just replaced. We didn't do anything yet. We replaced f of x plus h by what we just determined. We replaced f of x and we distributed -1. And we copied the h in the denominator. So 2 things must happen. Every time we're asked, we're given a function and we're asked to find the difference quotient. Please remember, 2 things have to happen. Okay. One of them, I would like you to put your phone on my desk.
Not on my phone.
Okay, put it over there, please. And your laptop.
I'm just doing work on the laptop.
What kind of work?
Math work, but not like that. Because I don't like the way you do it.
Okay,
You're not disturbing your class.
so 2 things have to happen here. The first step thing that has to happen is all terms at the top that do not have h must go away. If they do not go away, we have an error somewhere. The second thing that has to happen for any function, for any difference quotient, eventually this little h from the denominator must go away. So when we are done and we determine the difference quotient, there may be an h, it will be, an h left over in the expression that we come up with at the end, but not this h. This one must go away. So one more time, two things have to happen. The first thing that has to happen is everything at the top that does not have h must go away. Maybe that will be a bonus. Maybe some terms that have h may go away as well, but that's a bonus, which is good. Second thing that has to happen, this little h from the denominator must go away.
Okay, say those three things again.
Yes,
First
two
thing.
things have to
Two
happen.
things.
Yes,
Number
let's write
one.
them down. Very good. So here's the first one. All terms without little h must cancel out. That's the first thing. Number two, eventually, the little h from the denominator will simplify with an h from the numerator. Okay? So let's go back to the problem. So all terms without h must cancel out. Otherwise, we have an error somewhere. And eventually, h from the denominator will simplify with an h from the numerator. And if you want, we can write a third thing that has to happen. The final expression of the difference quotient will have h in it. If you want to write that down, we can. Good. So now let's go back to the expression. So I see a negative 3x squared with a positive 3x squared. I see a negative 4x, very good, with a positive 4x, awesome. I see a positive 2 with a negative 2. So is number one already fulfilled?
Yes.
We see that all terms without h indeed went away. Agreed? Perfect. So now let's take a look at the remaining terms. How many? Let's count them. 3. Do they all have a common factor?
H.
Exactly. So from here, yes?
The 3x squared has different signs, so they have to cancel out. They
Which
have
one?
different Negative 3x squared.
With a positive 3x squared.
So you can cancel out.
Negative 3x squared with positive 3x squared.
Oh, yeah. Sorry.
No problem. I'd rather go back and check. We may find a mistake. Who knows? So 1, 2, 3, h in common. And h to the denominator. Now see what happens next after we finish this. We simplify by h and we get 1. But I would like to figure out first what we have in parentheses.
Negative
Yes?
6x.
Awesome.
Minus.
Careful.
Oh, in order?
Careful.
No,
We already
no,
pulled out the
Oh,
h.
true.
We pulled out the h.
Minus,
All right.
Okay, minus 3h indeed.
minus 4.
And minus 4. Awesome. So what is the simplified form of the difference quotient then?
Negative 6x minus 3h minus 4.
Very good. So this is it. And those two things, initially it appeared to be very difficult, but I think you got the idea, right? So all terms without h must go away. The remaining terms have a common factor of h, they will, and that's how that h in the denominator goes away. Okay, so do you feel like doing another?
Yeah.
Very good. So let's make one up.
So that's the answer to the
Final answer.
Let's do one from the
so h equals -6.
No, the difference quotient for the function equals. So we started the difference quotient, and from here I jumped here, and from here I jumped here. So this is the difference quotient for the given function, negative 3x squared minus 4x plus 2.
Okay, alright.
Good. So let's come up with another function, any function you can think of, and let's determine the difference quotient, and then we can move on. We have to look at how to graph a piecewise defined function, and that's the end of this section, and we can move on. Okay, ready? Would you like to make one up, or would you like to choose one, or you trust me to choose another?
I'll try to find one from the book. Is this 2-2?
Yes, on page 252. Page 252, those problems are between 71 and 92. 71
see.
and 92 on page 252. Any problem?
Let's do 82.
82 it is. So in 82 we have a negative x squared minus 3x plus 1. Perfect choice. What type of function is it? What function did we pick?
Difference quotient.
Quadratic. It's a quadratic function. It has negative x squared minus 3x plus 1. Perfect. And now, yes, we want to find and simplify the difference quotient. Let's start. So the difference quotient is, you don't have to memorize this, but I think you already, once we solve a couple of problems like these, like the one from before, you should stick, but it doesn't have to. Which of these three pieces we don't have to work on, and which piece we have to work on?
F of x and h.
Yes, we do not have to work on these. These are clear. There is nothing we can do there. However, we have one piece in the difference quotient that is not clear yet. It's not, we haven't worked on it yet. Which one?
F of x plus 8.
Very good. So let's see what we have here. If anyone would like to dictate.
Negative
Yes,
x plus 8 squared.
but in parentheses, correct?
Right.
Very good.
Minus
Yes.
3 times x plus 8
Very good.
plus 1.
Right. Do we all see this? Do we all see this? Do we all agree with this step? We are given a function and we are asked to basically evaluate it when x is x plus h. And all we have to do is replace x all the way with x plus h. Is this clear for everyone? Yes?
Oh, okay.
Okay. So now I have to continue because I need to simplify it as much as possible before I replace it in here. Yes?
X
2 times the first times the second plus. Very good. Here I can distribute. There is no problem here. And then I do have one more step in which I distribute. Very good. So negative x squared minus 2xh minus h squared minus 3x minus 3h and plus 1. So far, so good? And now we have all three pieces. So I'm continuing from here, the difference quotient here. So please dictate what we have to write.
all that again.
Very good. Negative x squared minus 2xh minus h squared minus 3x minus 3h and plus 1. Very good.
Plus
Correct.
x squared
Very good.
plus 3x minus 1.
Perfect. That's it.
Or can we like
So now we know two things have to happen. Can anyone tell us what are those two things so we don't forget them?
Wait, why she switch?
all the
Oh.
So there is a minus that has to be distributed to all three terms.
Question, please.
Mhm.
So when you're replacing the f of x in the final
she did
solution,
last time. So
You mean here?
yes,
There is a minus in front that has to be distributed to all terms in f of x, not to the one or some of them, to all terms. Now, if it's easier for you, write it in parentheses and then distribute, if it's better. We're just lazy. We didn't want to write it twice. But if you need me to write it twice, I will.
No, that's fine.
Very good. So now what do we expect to happen first?
All the terms
Without
without H.
H. Maybe, as I said, some of the terms with H cancel out, which is fine too. We take it. So what terms will go away then?
X squared.
Negative x squared indeed with the positive x squared.
3x.
The negative 3x with the positive 3x. Awesome. Good. Perfect. So then, now what do you expect to do?
Write it out.
H parentheses.
Yes, factor out H. How many terms are there? Good. Do they all have H in common?
Mhm.
Otherwise, I can just simply pull it out. Very good. What is left in parentheses?
Minus 2x.
Perfect.
Minus 8.
Very good.
Minus 3.
Very good. So therefore, we have the simplified form of the difference quotient, which is? So we simplify. Indeed, negative 2x minus h minus 2. It looked difficult at first, but then once we got into it,
This takes up a whole half a sheet of paper.
that's true. Well, life isn't all that easy sometimes. Okay, last thing. Yep, we checked. Okay, so last thing that we need to look at in section 2.2 is what is called piecewise defined functions. Piecewise defined functions. Okay. I'm going to copy a function from your book on page 252. Let me see if there is any at the end something more exciting. If not, I can make one up because I don't. No, not too exciting. Okay. Okay. So let's look at problem 69 on page 252, and let's copy the problem first. So we have f of x and 0 if x is less than negative 4 is negative x if negative 4 less than or equal to x less than 0, and it's x squared if x is greater than or equal to 0. Why do you think that this is called a piecewise defined function? Because it is defined in pieces. How many? Exactly. One piece, the second piece, and the third piece. That's why this is a piecewise defined function. Okay. What is the first thing after we identify what type of function it is? What is the first thing we have to do? Or we have to find? What is that?
Wait a second. I'm still trying to copy this stuff down.
What X is?
Very good. Domain. Awesome. That's the first thing. I cannot get my chart or my table going unless I have the domain. Very good. So first we identify the type of function, and second thing is we have to find its domain. Ready? Perfect. So let's take a look at this. Can anyone give us the interval notation for x less than negative 4? And I know one of the questions on your mind is why do you need the interval notation? You'll see in a moment why.
The bracket, right?
So what does this represent in interval notation?
So parentheses,
Yes?
negative 4 is on. Negative infinity.
Very good.
To negative 4.
Awesome. With a parenthesis because there is no equal symbol. Perfect. This is done. I would like to do the same thing, the interval notation for the middle one. Very good. Bracket, yes. Comma. Very good. And then parenthesis because there is no equal symbol. Very good. Last one.
Question.
Yes, please.
Doesn't that one, so, this one, that second one got, have two?
So the equal symbol at -4, but no equal symbol at 0.
Oh, okay, I got you.
So now the third one. Yes? Yes? Comma? Yes. Is that clear? Greater than or equal to 0. To the right of 0, correct? This one says in between -4 and 0. And this one says less than -4, correct? Is this clear? Are these three intervals clear?
And they're clear, it's just,
I get it.
Good. Okay. So here's my next step, right? I did all this for two reasons. You're going to see the second reason in a moment. But the first reason is to find the domain. So let's see what we have. We have everything between -infinity and -4. We have everything. We have -4. We have everything between -4 and 0. We have 0. And we have anything from 0 to infinity. So can anyone establish for us the domain of this function?
Negative infinity to positive.
Do you all agree that this function is indeed defined everywhere? Yes? Yes? Perfect. Good. So I can get my chart going.
should that happen every time?
Yes, please. These are the steps for graphing any function.
Well, I'm saying, should the domain end up being?
No.
Okay.
No. So it's a very good question. We will select another problem in which the domain is not all real numbers. Very good point. You're, like always, way ahead of me.
Sorry.
That's fine.
Thing into the future.
Yes, you're way. I'm trying to catch up. Okay, so here's my next question. Which x values must be in the table even if we don't want them to be in the table? Why? Why? Because something major happens there, right? The function goes over a threshold from this outlook to this outlook, and then again to another one. So yes, -4 and 0 must be in the table. Now, please stay with me. This is the second reason why I did this. The first reason was to find the domain, and please watch what I'm doing now. I'm asking you, we all agree with this parenthesis facing left, right at -4. We agree? Good. So right under -4, I will create or write or draw a parenthesis facing left. In the middle, there is a bracket facing right. Under -4, a bracket facing right will touch the parenthesis. I'm just copying what I see here. I'm copying this and this. That's all I did. So I copied this symbol and this symbol under -4. Now, can anyone tell us what do I copy under 0?
Same thing.
Exactly. A parenthesis facing left and a bracket facing right touching. I know you want to ask why. Please bear with me one more minute. One more minute and you can ask. Okay. What I'm going to do next is an overkill, but I'm going to ask you which function do we use for x values between -infinity and -4 because I want to put it here.
Ask the question again.
Yes,
Right, what?
yes. For x values between -infinity and -4, which function will I have to use? Look at the first branch and tell me which function. Which function?
The first one.
Which is? Just read it and I'll put it in. Which function?
0.
Very good. Which function are we going to use between -4 and 0? I'm glad you're happy about this.
Nah.
Very good. Which function are we using for x values between 0 and infinity? Very good. Perfect. Now, you probably are asking yourselves, why is she putting them here? Don't I have them up here? Yes, but sometimes these functions are not presented in the correct order, and it's better to have them right on top of the domain for each piece. Perfect. So now, what type of a function is this?
I don't know.
The simplest possible on the planet. What is it?
0.
Linear. So this is a linear function. So how many points do I need for a linear function? Exactly 2. So let's say -5. And what do I get for y when x is -5?
0.
Perfect, of course. What do I get when x is -4? Correct. Now, you should say, wait a minute, you are not allowed to plug in -4 in this function. True? -4 is not here. The reason I asked you to plug it in is because if you don't plug in -4, then we have to plug in -4.000000000000001. Instead, I will plug in -4 and you'll see what happens. On the other side, let's plug in -4. What do I get? Inside the bracket.
4x.
When I plug in -4 in x, what do I get? Very good. 4 inside the bracket. So now let's plug in 0. And you should say the same thing. No, 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 no. You cannot plug in 0 because 0 is not here. Just bear with me and you'll see what happens. So let's plug in 0.
0.
Very good. Let's plug in 0 on this side.
Positive.
Good, if you want. And let's say also 1. Let's plug in 1. 1. Good. So now let's graph this function together. Please indicate the first ordered pair that we have to plug.
0, 0.
The first means from left to right.
-5.
Very good. So let me use green. So -5, 0. The next ordered pair, please. -4, comma. Perfect. But will that be an open point or a full point? Was I allowed to plug in -4? If I'm not allowed to plug in -4, it will be an open point. If I'm allowed to plug in -4, it will be a full point. It is an open point. So I'm graphing now 0 between -infinity and -4. And this portion of the graph is done. I cannot extend it to the right. This graph corresponds to the domain of -infinity, -4, and nothing else. Next in line, what do I plot? What type of point is -4 for?
Solid.
Yes, because of the bracket. Now you understand why I use the parenthesis and the bracket? Does it make sense? Good. The next point.
0, 0.
Will it be an open point or a closed point?
Open.
Yes, because it's a parenthesis. And I'm not allowed to plug in 0 here. Very good. So this is the straight line, which is -x. I'm done with the middle piece. I cannot extend it anywhere. This piece in -x is only between -4 and 0. You cannot extend it to the left. You cannot extend it to the right, as you cannot extend this one to the right. Finally, where are we now? So I have to go back and fill it in. What is the next ordered pair? Very good. And since I know that this is what type of function? Very good. It looks like this. We will address this function again. You studied it before. This is not the first time, but we will discuss it again in chapter 3. This is, oh, I need more examples. This is just the first one. No worries. So I would like to identify the range from here.
I see.
0 to infinity.
Perfect. From the lowest y value till the largest y value. Okay. Yes, please.
Can you go over how you got those numbers? Like you said, plug them in.
That's why I wrote the functions here. That's where I plug them in. That's why I wrote these. So when I plug in -5, there is nothing to plug in, so it's 0. When I plug in -4, there is nothing to plug in, so I get 0. The function is 0. For whatever value between -infinity and -4, the function is still 0. There is nothing I can plug in.
And that's why you just chose -5 because that's just the
I just wanted to show 2 points because it's linear. I just didn't want to just say show 1 point and then draw the line to your left without showing 2 points. Then here, when I plug in -4, the opposite of -4 is 4. When I plug in 0, I get 0. And this is a linear function as well. -4, 4 is this point, 0, 0 is this point, so this is the line. Then I reach 0, 0. Since these two numbers are the same, the function does not have a jump like here, and I have to fill it in. It starts at the same point. It ends at the same point. It starts at the same point. And then I have 1, 1, which is a quadratic function. It has to go up. Better? And again, this is just the first example. So let's come up with another. Yes, please.
Is there like some menu in the calculator that does all of this?
Yes, you can graph it with the graphing calculator. However, you will not be able to show me the graphing calculator when test comes, right? Copying a graph from the graphing calculator will not bring you points. That's what I'm saying. I can't. Are you going to come in and say, hey, look at my graph?
I'm sorry. Maybe. Wait, can we get a cheat sheet?
No.
What?
No cheat sheet.
How about, so
I mean, a function cheat sheet. Like,
the formulas never change. We should be allowed to have formulas.
okay, that's fine.
And we can negotiate later. So let's look at another example. So would you like to make one up, or we can make one up together?
Stop giving us the easy one. Let's get a trick.
Okay, very good. So you would like a two-piece?
That wasn't.
Which one? 68. Very good. So we picked 68. 68 has -1/2 x squared for x less than 1, and 2x plus 1 for x greater than or equal to 1. I was going to show you one with that does not have domain all real numbers, as I promised, but that's fine too.